Man school, a proponent of Eastern region. No, Clapman. Oh, okay. So we'll continue from where we left the other time. And I'm going to off your camera, your phones, your microphones for now. Where there is a need for me to open the microphones, I will do that. Last time we looked at the definition of sets. We looked at the types of sets. We also looked at the simplification of sets. Today we are going to look at the 4 basic operations on sets: addition and subtraction, multiplication and division. Good. So we'll start with addition and subtraction. Like how we have in normal algebra, like sets and like terms and unlike terms. When it comes to sets, we also have like sets and unlike sets. So let's pick an example. In algebra, if I have x plus 3x minus 2y plus 4x squared plus 3y, and I'm asked to perform this operation, I can only perform the operations on like terms. So this and this are like terms, but because of the square here, the 4 is not 4x squared is not a like term to the 3x. So we can add this to get what? 4x. Then the minus 2y and the 3y are also like terms. You can also combine them together to form just y. But the 4x squared doesn't have any like terms, so it will come. When it comes to sets, we also have what we call like sets. If we look at the algebra that we did, when we want to look at like terms, your emphasis is on the variables. That is where your emphasis are, to be able to identify whether a term is a like term to the other. Once you have identified the like terms, you only add the coefficients. So in the first one in yellow, we got a 4x by adding the coefficient of x, which is 1, to the coefficient of this 3x, which is 3, to get 4. And we just wrote 4x. Similarly, the negative 2 here was just added to the 3, and then we got 1, and then we attach the y to it. So this is 1y. But you know, in algebra, we don't write the 1. So the same rules that we know in algebra also plays when it comes to addition and subtraction of sets, or all the basic operations involving sets. For instance, I can have 3 root 2 plus 5 root 11 minus 6 root 2 plus root 11. If I'm asked to simplify this, I will focus my attention on the sets, the radical parts, these guys, the root 2, root 11, and then if they are the same, the radical part are the same, Then we say that they are like sets. Then, as we did with the algebra, we are going to add the numbers that is attached to these sets. So with this example, the 3 root 2 is a like set to minus 6 root 2. So you only manipulate the numbers that are attached to the root 2. So to be 3 minus 6, there's no need for you to do this. Write the 3 minus 6 in brackets. You can actually do it mentally. But I just want you to appreciate it. Then when you come here, the root 11, 2, they are also like terms. So the numbers attached to them will also be combined. Remember, as in algebra, if I have x, the number attached to it is 1. So if I have root 11, the number attached to the root 11 is also 1. That is why we have 5 plus 1 here. So here will be negative 3 root 3. And this side will be 6 root 11. Okay. Let me open the microphone so that if you have a question, you can ask.
So please,
Okay.
how
Yes.
did you get the 3 minus 6 root 3?
Okay. Any other question again before
That
I
was me.
continue? Maybe I'll.
So this is the same question I had. So there's a mistake.
Please, sir,
Okay,
the
so let's
same
see.
question.
3 minus what? Also, sorry, supposed to be root 2. Thank you very much.
Yes.
Yes, sir.
Supposed to be,
So please, we are
supposed to be root 2.
confused.
So are you okay?
Yes,
Yes,
sir.
sir. Yes, sir.
Good. So sorry for that. It's supposed to be root 2. Any other clarification? If you have any other question, no question. Hello. If there's no question, then we are doing more examples for you to understand more. Okay, so let's go to the next example. Let me put off the microphone for now.
Sir, please wait. Sir, please wait.
Okay, so another example. So we have to add 5 root 2 to 3 root 2. So these are like said. So we only add the numbers attached to the sets. So to be 5 plus 3, as I said earlier on, this one, you can do it mentally. So you are going to get what? 8 root 2. Let me just bring all this. Then let's look at another question. Two root 5 minus 5 root 2, 5 root 5. They are like said, so manipulate the numbers attached to them. So to be 2 minus 5, that is negative 3. Then you attach the root 5. Then let's look at some examples that will involve simplification. Let's look at this one. For the third question, at the initial stage, You may think that the numbers or the sets are not like sets, but they are, unless you simplify them. If you don't simplify them, you will not know that they are like sets. So you have to first simplify all the sets to its simplest form, like how we did the last time. So since you know that already, we'll have to write 147 as a product of two numbers, such that 1 is a perfect square. So who can give me those two numbers? Yes. Some hands are up.
49 times 3.
Let's go to Grace
49
Berry.
times 3.
Please,
What
let me
times
mention your
3?
name before you. Let me mention your name
Sir,
before
please
you.
seven times.
Grace
Sir, please
Berry.
seven times 3.
Are you Grace Berry?
Sir, no.
So let's mention your name before and that there'll be chorus answers.
Sir,
So
please my name
Alice, when you want to talk, you raise up your hand. I'll mention your name. Alice. Alice, your hand is up. You can speak.
Sir.
49 times 3.
Okay, 49 times 3. So this is going to be root 49 times root 3. What about a 75? Yeah, 75.
Root 25 times root 3.
Raise, hey,
Root 25 times root 3.
please, you raise up your hand, I'll call you. Other than that, the class will be so noisy. I've got it. Let's make it orderly. Good. So that is going to be root 25 times root 3. Then what about the 27?
9 times 3.
Hey. So root 9 times root 3. So when you find the square root of 49, which is a perfect square, that will give us 7. So this one was simplified as 7 root 3. Then the square root of 25 is 5. So 5 root 3. And the square root of 9 is 3. So 3 root 3. Now that we have simplified it, we can see that, in fact, all the sets are even like sets. So we can straight away add the numbers attached to the sets or subtract them. So 7 minus 5 plus 3. 7 minus 5 will give us 2 plus 3 will give us 5. So this will give us 5 root 3 as our final answer. Good. Good. Any question? Okay, if there's no question, then we can continue. Let's look at another question. This one, I'll allow you to do it and give me the final answer. So I'll put that one on the next page. So when you are done, you raise up your hand and then give me the answer.
No.
Senior Kafi, what did you get?
Sir, please. 1 root 6.
1 root 6. So you can just say root 6. That is senior. Roy.
Yes, I had root 6.
Roy also had root 6. Reginald Ganser. Reginald. Okay, let me go to Erica Biu. Your hand is up.
7 is root 6.
Okay, root 6. So now let's start solving and see whether your answers are correct. The 24 can be written as 4 times 6. That's the square root of 4 times the square root of 6. Then, for the second term, it's already simplified because root 6 cannot be written as a product of two numbers where one is a perfect square. Then we go to the 236. For 216, we can write it as 36, square root of 36 times what? Square root of 6. I hope we all had that. Then the last one, which is 294, can also be written as 49 times 6. The square root of 49 times 6. Good. So this will give us 2 root 6 minus 3 root 6. Then 6 root 6 plus 7 root 6. So we are just going to add their coefficients. 2 minus 3 will give us negative 3. Negative 1, sorry. Then negative 1 minus 6 will give us negative 7. Then plus 7 should give us 0. So it wasn't root 6. It was rather 0. Or better still, let me write it this way so that you understand. So we have 2 into bracket 2 minus 3 minus 6 plus 7 root 6. So everything here will be 0. So 0 root 6. And 0 times any number is 0. So the final answer should be what? 0. Okay. Any question about that?
No, sir.
No, sir.
Reginald.
No, sir.
Okay.
Sir,
Sir.
sir,
Florence.
No.
sir, please, I just
Sir.
joined, so I don't know what's going on.
Okay. It's quite unfortunate if we say we should repeat what we have done to. It's not going to be an advantage to those who have also joined, wasted their data from the beginning. We are doing addition and subtraction of sets. So later on, you can watch the video. We are recording the session. Okay, so let me give another one again to try before we go to multiplication. We have 3 root 500 minus 2 root 125. So I'm giving 1 minute to try. Alice, your hand is up. Alice, or it's a wrong hand. If it's a wrong hand, you lower your hand.
Oh, no, sir. Please, I've solved this question before and I want to give out the answer.
You know it already. Okay,
Yeah,
so what
I've
did you?
solved this question before.
I
20
hope you are
root
not.
2.
You got 20 root 2. I hope you are not pressing calculator.
Sir, please, I'm not using calculator.
Okay. Friends, Yama. Chief Kofua,
Sir, 20 root 5.
20 root 5. Florence Bila,
20 root 5 minus 10 root 5. I mean, 20 root 5.
So you got 3 root 5.
20 root 5.
20 root 5.
No, 20.
Please raise up your hand. If your name is
20
not
root
called,
5.
you pay
20 root
attention.
5.
If your name is not called, don't speak, please. Samuel Amwa,
20
just
root
raise up
5.
20 root 5. Akpabli,
Say 20 root 5.
okay. Nana Abena, then the last person, Roy,
Say 20 root 5.
20 root 5. Okay, so that's all.
20 root 5.
So I'm muting the microphone for now. Let's all see which one is correct. So the 3 is here. We have to simplify we know the 3 is multiplying the root 500, so I can write times. So root 500 can be written as root 100 multiplied by root 5. 100 is a perfect squared. Then minus 2 also multiplying 125. The square root of 125 can be written as the square root of 25 times the square root of 5. The square root of 25 is a perfect square. So we'll find the square root of 100, that is 10, root 5. Then the square root of 25 is 5. When we perform this multiplication, the whole numbers, it will give us 30 root 5. And this will give us 20 root 5. So when we subtract these numbers, 30 minus 20 will give us 20 root 5. And that is the correct answer in this case. So those who said 20 root 5, they had it. Okay. Samuel Amwa, your hand is up.
Sir, please, a mistake.
Okay, Nana Yeboah.
Sir, please, a mistake. It's supposed to be 10 root 5, not 2
Oh,
times
okay,
5 is
okay.
10. 2 times 5 is 10.
Times 5 is 10, yeah. So, yes. Thank you very much. Good. The answer 20 was in my mind. Good. It means you are following. Thank you very much. That is great. So if there is no other question, then we'll move on to the next session. And that will be multiplication of sets, multiplication and division of sets. Good. It's also like how we do algebra. When you have two terms multiplying, x multiplying maybe 3x multiplying 4x. In algebra, we multiply the numbers. Then we multiply the variables. So the results here is going to be 12. Then the x times the x will give us x squared. Another example, I can have 5x multiplying 2y. Similarly, the numbers will multiply. Then the variables will also multiply. So when the numbers multiply, we'll have 10. And then when the variables multiply, because they are not numbers, we can't find their value. We just write them like this, xy. Xy means x is still multiplying y. You can also have just a single number, let's say 10, multiplying a number that has a variable. So maybe 2x. The number will just multiply themselves. Then we attach the variable to it. This time around, there's no variable to multiply. So it will just attach to it. So it will be 10x. This is how we do in algebra. So we are going to apply the same knowledge when it comes to sets. So for multiplication of sets, we do not consider like terms or like sets. Whether the sets are like or not, they can multiply. The same way in algebra. When the numbers or the terms are like or not, you can actually multiply them. There are some few hands up. Let me open the microphone and listen to them before I continue. Cherish.
Sir, please, there is a mistake. 10 times 2 is supposed to be 20, not 10.
3 times.
Yes, sir.
Please, the last one, 10 times 2 is supposed to be 20, not 10.
20.
Please,
Okay.
Yeah.
20. Okay, thank you very much.
Okay.
Nana Yabua.
So I wanted to also say the same thing.
Okay, so that's good. That means you are following keenly. So now let's box on. We are now come to apply the same knowledge with sets. So when we are multiplying sets, so let's look at the first example. For example, we have 3 root 5 multiplying 2 root 3. The result is going to be 3 times 2 for the whole number part, which is 6. Then the set will also multiply. So root 5 times root 3 to give us root 15. Then you ask yourself whether the root 15 can be broken down. Sometimes after multiplying, you will get a number that can be broken down. When is it broken down? It means that you can be able to express it as a product of two numbers where one is a perfect square. But we know 15, there is no a factor of 15 that is a perfect square. All the 15, the factors of 15, none of them is a perfect square. We have 1, 3, 5, and 15 itself. None of them is a perfect square. So it means this one cannot be broken down further. So this becomes the final answer, the product of these two cells. Good. You can have root 2 into bracket 6 root 3 plus 1. So if you are multiplying, this is a bracket, and you open the bracket as such. So the root 2 will multiply the first term in the bracket and also multiply the 1. That is how we open brackets. So root 2, when we are multiplying the root 2 with 6 root 3, it's like as we had 10 multiplying 2x. Only the whole number part will be multiplied. So we have the 1 will multiply 6, and we have what? 6. And then the third will also multiply, and we have root 6. Then root 2 times 1. Any number times 1 is the same thing. So that will give us root 2. The third cannot be broken down further. The root 6 cannot be broken down further. The root 2 can also not be broken down further. And the two are not like sets. So we can't simplify further. We'll leave it as such. Nana Yabua hand is up, so let me listen to Nana Yabua. Okay.
Oh, sir, sorry, it was a mistake. It was a mistake.
Gloria, let me listen to you.
Sir, please, how did you get the square root of 2?
Where? Here? Is it this one?
Sir, please, yeah.
Good. I said
No, please, the first one.
this one.
Yes, sir.
Okay, this is question 2. So that's the question itself.
Okay.
That's the question itself.
Okay, sir. Thank you, sir.
Good. Then let's go to the next person, Akromia. Okay, Akromia hand is down. So let's go. Henceforth, then that'll be all. Then we'll do example 3.
Sir, please, can you explain how you got the answer again?
Okay, so the root 2 will multiply. Root 2 will first multiply 6 root 3. So as we said, the whole numbers will multiply. The numbers attached to the set. If I have root 2, we have 1 in front here. So that will multiply the 6. Then the root 2 will multiply root 3. The radical part will also multiply. So root 2 times root 3 will give us root 6. So that gives us the first one. Then as we open bracket, this will also multiply the 1 again. So root 2 times 1. And we know the properties of 1. Anytime you multiply 1 by anything, it is still the same thing. So root 2 times 1 is still what? Root 2. So that gave us the second term. Good.
Okay, I now get it. Thank you very much.
Okay. So let's look at another example. 4 minus 3 root 2 in one bracket, multiplying 5 minus root 2 in another bracket. They are multiplying. So to perform this multiplication, we do the same thing as we do in algebra. 4 will multiply everything in the bracket here. And then the second term here, minus 3 root 2, we also multiply everything in the bracket, the second bracket. Good. So let's open the first bracket. 4 will multiply 5, we have 20. And 4 will multiply root 2. It's minus root 2. So they give us minus 4 root 2. Then minus 3 root 2 will multiply 5. So the whole numbers will multiply. So this will give us negative 15 root 2. Then the root 2 will multiply minus root 2. Minus 3 root 2 will multiply minus root 2. So the numbers here are negative 3 and negative 1. The numbers attached to the set. So when they multiply, they become positive 3. That's negative 3 times negative 1, the number outside here. Then the set will multiply together, you can write it in two ways. You can write it as root 2 squared. Root 2 squared, because when you have x times x, it will give what? X squared. You can actually also write it as what? The square root of 4. Good. Well, let me use root 2 squared. Then we can simplify this further, unlike the others, because we have like set. So we have 20. The like set here, minus 4 root 2 minus 15 root 2 will give us negative 19 root 2. Then this side, the square root will cancel the square. So we'll be left with 3 multiplying 2. Good. So let's continue. We are going to have 20 minus 19 root 2, then plus 6. The 6 is coming from the product of 3 and 2 over here. Since this is a whole number standing on its own, and this is also a whole number standing on its own, we can join that together to form 26. That's 20 plus 6 minus 19 root 2. Let me listen to Nshira Nyamiche. Your hand is up.
Sir, please, I didn't get that part.
Which part? Is it the final part?
The previous one.
Okay, so before I go on, I answer you. Let me listen to Cherish first. If Cherish is not ready, let's go to Gloria. Aidan.
Sir, please. The one I did is 3 square root of 2 into bracket square root of 2 into bracket exponent 2. Sir, please, can you do it 3 into 3 square root of 4?
Yes, I said that here, that you can actually write it in two ways.
Okay. Sir, please, and when you do it 3 square root of 4, how are you going to solve it?
Good. You see here, we cancelled the square with the square root, and we got 2.
Yeah.
And here too, you can find the square root of 4. What is the square root of 4?
2 times 2.
No, that's not the square root of 4.
Hey.
So,
It's
so
just
is the
2.
Square root of 2.
No, the square root of 4 is just 2.
It's 2. Okay.
The square root of 4 is just 2. So when you write it this way or you write it that way, you are still going to get a 2.
Yes, sir.
Good.
Okay.
Then,
Thank you.
Okay, welcome. Jonathan. If he's not ready, let's go to Ernest Ajiman.
Sir, please, why is it that when you got the 26 minus 19 root 2, you didn't subtract the 90 from the 26?
Good. Because they are not like sets. This is just a constant number, an integer. Remember, if it is algebra, if I have 26 minus 19x, you can continue again. Is that also? Can you subtract
Yes.
19? Good. So the same thing that is happening here. I said we are applying the knowledge of algebra. But if there was an x here, we could have subtracted. So it means if it was 26 root 2 minus 19 root 2, then we could have subtracted the 19 from 26. Like how we did with the addition and subtraction. Good. One of the first question was that the first concern was that she didn't actually get the whole thing. So let me just go over quickly. Let me go over this quickly. Good. Let me use algebra to explain this. X minus 2, x plus 3. If you're asked to perform this multiplication, the x will multiply the second bracket, and the minus 2 also multiply the second bracket. Opening of bracket, expansion. So x times x will give us x squared. X times 3 will give us 3x. Minus 2 times this will give us 2x. And then minus 2 times 3 will give us minus 6. Then if there are some like terms, you perform. So these are like terms. So we have x squared. The 3x minus 2x will give us just x minus 6. So that will be the results. So the same thing that we are doing here is the same thing. So we have the first bracket multiplying the second bracket. So what we'll do is that every item in the first bracket will multiply every item in the second bracket. So the 4 is going to multiply the second bracket. That's what we have written here. Then the minus 3 root 2 will multiply the second bracket. That is what we have written here. So what is left is that we open the bracket in each case. 4 will first multiply 5, and this is the results. And 4 will multiply minus root 2. It's like maybe 4 multiplying a variable. If 4 is multiplying maybe x, you get 4x. So 4 is multiplying root 2, you get 4 root 2. And in fact, it's negative, so it will be negative 4 root 2. Then when we come here, we are multiplying negative 3 root 2 by 5. So it is only the whole numbers that will multiply, then you attach the set to it. So negative 3 times 5 will give us negative 15. Then you attach the root 2 to it. When we come here, the numbers attached to the sets, we have negative 3 and negative 1. So the numbers will multiply, you get positive 3. Then the set will also multiply. So root 2 times root 2 will give us root 2 squared. Or otherwise, if it was x times x, you get x squared. You can actually write it as what? Root 4. As somebody asked and I said. Good. Then the rest is just to simplify the expression. These two are like sets, so they can be simplified. Like said, you can take it in algebra, you can take it like maybe negative 4x minus 15x. You get negative 19x. So negative 4 root 2 minus 15 root 2 will give us 19 root 2. And here, the square root will cancel the square, and just we're left with 2. So the next page, what we did was to multiply the 2 with the 3. And we had 6. And 6 is a like term to the 20, so they can be added. So we added the 6 to the 20, and that gave us the 26. But the minus 19 root 2 is not a like term, so we cannot continue from this further. So this is how far we can simplify up to. Good. I've seen a lot of hands up, so let me listen to them. I have Ganiyu Adams.
Please go back again. Sir, please go back again.
I should go back to the previous page.
Yeah.
Please go back again. We just joined.
No, those who are late there, we can't repeat. If you can't see the board, then you have to leave and join. That is sometimes that's the problem why you can't see the board.
So we weren't given the timetable.
The timetable is on your dashboard when you log into the portal. And 10 minutes to the time, you always get an SMS notification. I started the moment I click class start, you get an SMS notification. So when you log into the portal, after this class, log into the portal and take note of your sessions.
Okay, sir.
Your sessions for tomorrow. Maybe there might be another class even after here, 7 o'clock. So that you don't get. But the good thing is that the session is being recorded.
Okay.
So you will still get it in the portal and watch later on. But if you say we are repeating, those who have joined from the beginning will just be wasting their data.
Okay.
Okay, so
Sir, thank you.
thank you very much for also understanding. Erica Biu, I'll listen to Erica
Hello, sir.
Biu and then Husseini. Yeah.
Sir.
Abiu,
Sir.
I've given you the platform.
Sir, please, when we're subtracting -4 plus -15 plus -6, I got -25. So I tried to
Where did you get
confirm
it?
it was you got
You said you added
-26.
I got positive 26. The final answer. Let's go back to that place. You said, what did you get? Come again.
Sir, please, it's okay. I'm okay.
Okay. Then the last person I said, Hussein Tijani. Okay, if Hussein is not ready.
Sir, please, you said what?
Your hand is up, so that's why I've called you if you have anything for us. If you have nothing, then you have to put down your hand. Then, Jonathan, your hand is also up. Okay, so that is all. Let's move on.
It's not me.
Let's move on. So we are moving on. Let's move on for the meantime. If you have further questions, you can ask. So this time around, I'm coming to give you some to try on your own. Okay? And let's see how you'll be able to do it. So let me put that on a fresh screen. So we have one bracket, √3 minus 1. Another bracket, 2 minus √3. So try this in 1 minute. 1 minute is too far. Try this in 30 seconds. We can do this in 30 seconds. I believe you. So when you are done and you know the answer, you can raise up your hand. Okay, Edward said he has finished.
So please, the answer is 4√3 minus 5.
4√3 minus 5.
Yes, sir.
Let me write it here. Minus 5. Okay. So by convention, you have to write it as -5 plus 4√3. We say we normally write the whole number part first. Remember? We discussed that. But it's not wrong, though. Let me go to Kari Gemfi roots. Gemfi. If she's not ready, let's go to Esther Isinam.
So please, I had -5 plus 3√3.
3√3. Okay, let's go to Roy.
So please, I had 4 minus 3.
4 minus 3√3. Then let's go to Audrey Esuman, the last person that would all try it together. Audrey Esuman.
I have 3√3 minus 5.
3√3 minus 5. And I said, by convention, write the whole number part, the integer first. So it will be 5 minus 5 plus 3√3. Okay, but let's look at how the expected solution. So √3 will multiply the next bracket 2 minus √3. Then minus 1 will also multiply the same bracket. minus 2 minus root 3. Good. When I multiply this by this, you get 2 root 3. When I multiply this by this, I'll get root 3 squared. Or you can write root 9. When I multiply this by this, I'll get minus 2. When I multiply this by this, I'll get positive, negative, negative. So positive root 3. Good. So the roots here can add root 3. They can just add straight away. So we have 3 root 3. That is, I'm adding the 2 root 3 plus the root 3 here. So that'll give me 3 root 3. Then for this side, the square root will cancel the square. So I'll be having minus 3 minus 2. So 3 root 3 minus 5, or negative 5 plus 3 root 3. So let me glance through and see those who had it. This is wrong. It's the same thing as this. Minus 5 plus 3 root 3 is correct. This is wrong. This is wrong. This is correct. Good. Let's look at another one. This time around, I want all of you to have it correctly. So I'll put that one too on the next page. So in 30 seconds, let's find the value of this 1. 2 plus 2 root 7 minus 5, sorry, to bracket 5 minus root 7. Okay, so if you are ready, this one in 30 seconds, you should be able to do it. Okay, we have Adelaide. Adelaide said she has finished. Let me open the microphone for you.
Please, my answer was negative 4 plus 7, negative 4 plus 8 root 7.
Okay, negative 4 plus 8 root 7. Then let's go to Gansa.
So negative 4 plus 8 root 7.
The same thing. Okay, let's go to Edwin.
Negative 4 plus 8 root 7.
The same thing. Okay. Then the last person, Alice.
Negative 4 plus 8 root 7.
Okay, so let's all solve it and see whether it is indeed true. So 2 will multiply 5 minus root 7. Then plus 2 root 7 will also multiply 5 minus root 7. Good. Then we'll multiply these two numbers. That'll give us 10. Then multiplying the 2 by the root 7 will give us minus 2 root 7. Then when we come here, 2 root 7 times 5 will give us 10 root 7. Then 2 root 7 times root 7 will yield minus 2 root 7 squared. We have some like said here. So minus 2 root 7 plus 10 root 7 will give us 8 root 7. Then obviously we know that this will cancel, the square will cancel the square root. So we have minus 2 times 7, and that will give us minus 14. Oh, sorry. So it's 14. Everything here is 14. I wanted to put the 7 in bracket. So let me just, the whole thing here will give us minus 14. I hope you agree. Then we subtract the 14 from 10. That should give us negative 4 plus 8 root 7. So all of you did well. Very good. It's excellent. Very good. You did well. We have only 2 minutes left. I would have loved for us to do another one. go to another concept, but because of time, let's just do one last question so that next week when we meet, we'll start with the conjugate of sets. Conjugate of sets. So let's do the 2 minutes for one last question. I hope the hands that are up are old hands. So I have lowered them. I've lowered all your hands because I believe they are old hands. We have 1 minute left, so let's not waste time. So let's go to Dorinda Ofori. What do you have? Dorinda Ofori, what do you have? What did you get? Your hand is up.
Sir, please. Is it 1 out of 3?
It's one out of, it's 1 out of 3, yeah.
Okay.
It's
Thank you.
1 out of 3. Reginald Gansa.
10 plus 4 root 3 all over 3.
Okay, then we go to Adelaide.
Negative 14 out of 5 plus 4 root 3 over 5.
Negative 14 over 5.
Yes, plus 4 root 3 out of 5.
Okay. Let's go to Lamti.
I raise my hands.
Yes, Lamti. If Lamti is not ready, let's go to Fuseni.
Sir, please. I got the same as Adley.
Okay, so then let's quickly, it's time, so let me quickly solve this. We have 1 multiplying 1 over 3 plus root 3. Then minus root 3, also multiplying 1 over 3 plus root 3. So 1 times anything is the same thing. So obviously the first bracket will not change. Then minus root 3 times 1 over 3 to give us minus root 3 on 3. Then we have root 3 times root 3 to give us root 3 squared. So we have 1 over 3. We have some like said here. So let's add them. Because this is a fraction, we are going to use the idea of addition of fraction. The LCM is 3. So 1 goes into 3, 3 times the numerator will give us 3 root 3. 3 goes into 3 1 times the numerator will give us the same root 3. Then, obviously, we know from previous experience that the square root will cancel the square. So we'll just have minus 3 here. Good. This minus 3 is also over 1. So we'll come and then perform that subtraction. So 1 over 3 minus 3 over 1. Here we can subtract the numerators. So 3 root 3 minus root 3 will give us 2 root 3 on 3. Then the whole numbers here, let's perform that subtraction. The LCM is 3. 3 goes into 3 how many times? 1 times the top will give us 1. Then 1 goes into 3 is 3 times the top will give us minus 9. So plus 2 root 3 over 3. Then we subtract this to give us minus 8 over 3. So the final answer is minus 8 over 3 plus 2 root 3 on 3. So that is all for today. I will just reserve some few minutes, just 30 seconds for questions. If there's no question, 30 seconds, because it's 7 o'clock. There's another question.
I sent somewhere.
So Dorinda, do you have a question for me? Your hand is up.
No, sir.
Yes.
I do not understand. Can you please start it?
Sophie, can I have your question?
Yeah, please. I don't understand. I don't understand how you got the minus. The 1 over 3 minus 3 over 1. I don't know why you got the minus there.
1 over 3 Here.
Yeah.
It is coming
Below
from
it.
here.
Only that place. I don't understand.
I was just grouping items, so I just brought this one here.
Oh, okay. I understand. Thank you, sir.
Okay. Please mute yourself if you're not speaking, if you have not called to speak. Also, I'll just randomly pick those, so many hands. I'll randomly pick 2. So randomly picking 2, as well as those who have not spoken. Boy, and spend the love. Your hand is up. Okay, Godfred Boache. Your hand is up. Okay, so that is all for this evening.
My hand is also up.
Yes, it is time. There's another class. If I take all your questions, I might eat into the next class.
Sir, please, the
So
attendance.
we'll meet. You will meet again next week. They said they will give you. They will give you a link for you to mark yourself. I think so.
So I said I'm asking.
For attendance, I think they will give you a link.
You have to give us the link.
Is that so? Okay, let me check if that thing is activated on the portal. Just 1 minute. Let me be sure. No, it is still QR code, and the QR code. Most of you say you can't scan. Or can you scan now? If you can scan, then let me just show you the QR code. Oh, let me just share entire screen. So this is the QR code. Those who can scan, you scan. Let me just stop the recording for the meantime, because you are done.